This is an example how we can use the time function from the C library or the getCount function from the Windows API to determine if our application might be running in the debugger. I've written a simple program, so I will quickly go through this program. At first, it just allocates some memory. Then it generates some pseudo random numbers, and these numbers they get saved in the allocated memory. Then the array gets printed, and now the time function gets called, so it just saves the seconds that have elapsed since 1st January 1970, and yeah, the result gets saved in seconds 1. Then a bubble sort algorithm gets called. It just sorts the number in the allocated memory, and then there's a second call for the time functions, and the result gets stored in seconds 2. And now this is the important part. This is where the seconds 1 and the seconds 2 and the seconds 1 variable are getting compared. So when the result in seconds 2 is bigger than in seconds 1, then this block will get executed. So when I just execute this program now, nothing special will happen. It just prints array, sorts it, and then prints the seconds. Now I will open everything in the debugger. I've analyzed the code already, so I've made some notes. So this is where we currently are. There was a first call for the time function. The result or the return value from this function, the data gets saved in EDX, and it goes to EDX, and then it goes from EDX to RBP minus 1C. So the first call, this is RBP minus 1C, and I will keep stepping through the program. This is now the part where the bubble sort algorithm gets called. And here's the second call for the time function. And again, from EDX, the data goes to EDX, and then from EDX to RBP minus 20. And this is now important. This is where these two variables get compared. So the comparison is between RBP minus 20 and RBP minus 1C. And if the result in RBP minus 20 is bigger than the one in RBP minus 1C, then the program will go into this block. So it will say now debugger detected. And why is this the case? So here was the first call for the time function. The result is saved RBP minus 1C. And maybe we can just restart it. Okay, so here's the first call. Okay, so it's now executed and the data is EAX. Now if I keep stepping through the code, of course, this will take some time. And then here's a second call. So there's a time difference between the first call and the second call. And that's the reason why we have now a time difference. And that will run again at the debugger detected block. So it's no problem to execute the program just like this. It's no problem, at least if the execution of the sorting algorithm doesn't take too much time. So when it takes more than 1 second, then it will run into this block. So for example, the numbers a little bit bigger. After the sorting, it will run in the debugger detected block. And there was a time difference of 4 seconds, so it's not the best method for measuring execution or function executions, but this should be good enough this time. So it was 4 seconds. Let's say 8 seconds for the time difference. So when it takes more than 8 seconds to execute this algorithm, then it will run as a debugger detected block. But as we have seen already, it took just around 4 seconds. And now we can see everything is just normal to execute. Nothing special. And now we'll open it again in the debugger. So this got executed already, and the counter is basically ticking. Now we'll execute the bubble sort. Okay, it's executed. And it runs again. And the debugger detected block. And yeah, that's the logic behind this anti-debug function or method.